Next question. For each natural number n greater than or equal to 1, let an equal to n by 10 power ceiling function of log n base 10, where ceiling function of x is nothing but smallest integer greater than or equal to x. Which of the following statements are true? This is the question. Actually, they have given 4 options. Those 4 options are dealing with limit infimum and limit supremum. So, if you find limit infimum and limit supremum of the sequence an, then we can easily answer for this question. So, in order to find limit infimum and limit supremum, first of all, we need to know the behavior of an or all properties of an. They have clearly given an equal to n by 10 power ceiling function of log n, where the base of log is 10. Now, in order to know the behavior of the sequence an, first of all, we need to know the ceiling function of log n. So, I try to enumerate the values of log n. Obviously, log 1 is 0. Whenever you have 10 power something, for example, if you have 10 power k, then the value of log 10 power k is k, because here the base is 10. We know that. Also, we need to know log n, where base is 10, is strictly increasing. Actually, whatever may be the base, log function is a strictly increasing function. Therefore, when you look into 0 and 10, the numbers in between 1 and 10, definitely we have the function should be increasing from 1 to 10. Now, we know that log 10 is 1. We know that log 1 is 0. So, in between, the numbers in between 1 and 10, the log values should lie in between 0 and 1. Actually, 0 is strictly less than log n, which is less than or equal to 1. You can verify this. In the similar way, if you consider the elements, the numbers n in between 11 and 100, definitely you have the value of log n is less than or equal to 2 and strictly less than 1, greater than 1. In the similar way, if you consider the values of n in between 101 and 1000, you will get the log value 2 less than or equal to log n less than or equal to 3. In the similar way, it goes on. Now, if you know this value, from this value, we can find the ceiling function of log n, which is displayed here. Log 1 is 0, therefore the ceiling function of log 1 is 0. From 2 to 10, the value of log n lies between 0 and 1, but the value of log n is not equal to 0. That means it is greater than 0 and less than or equal to 1. Therefore, the ceiling function of log n is equal to 1 if 2 less than or equal to n less than or equal to 10. In the similar way, if 11 less than or equal to n less than or equal to 100, the ceiling function of log n is equal to 2, and so on. So, we know that how the sequence is going. Actually, the sequence is going 1, 0.2, 0.3, and it goes on. At the 10th term, we have 1, and it goes on. Actually, I have given the sequence an equal to n by 10 to the power of log n. The sequence is represented below. 1, first term of the sequence is 1, second term of the sequence is 2 by 10, because when you take n equal to 2, 2 by 10 ceiling function of log 2. Ceiling function of log 2 is 1. Therefore, here you have 2 by 10, that is the value. In the similar way, when you take n equal to 3, you have 3 by 10 power ceiling function of log 3. Ceiling function of log 3 is nothing but 1. Therefore, 3 by 10. So, up to 10, you have ceiling function of log n is 1. Therefore, at the 10th term is 10 by 10. Again, you will get 1. When you come to 11th term, the ceiling function of log 11 is 2. Therefore, A11 will become 11 by 100. In the similar way, A12 will become 12 by 100, and it goes on up to 100th term. 100th term is 100 by log, the ceiling function of log 100 is 2. Therefore, 100 by 100 will become 1, and it goes on. If you Therefore, the sequence is 1, 0 0.2, 0 0.3, 0 0.9, and it goes on. 10th term is 1, 11th term is 0.11, 12th term is 0.12, and it goes on. If you observe the sequence, definitely we can conclude that whenever you have a 10 power of something, for example, if you have the value of n is 10 power of something, for example, if you take 1, 1 is nothing but 10 power 0. If you take 10, 10 is nothing but 10 power 1. If you take 100, 100 is nothing but 10 power 2. In the similar way, if you take 10 power something, then the value of the term is 1. We can observe this. First term is 1, 10th term is 1, 100th term is 1, 1000th term is 1, 10,000th term is 1, and it goes on. In the similar way, in between 1 and 100th term, first and 100th term, the minimum value is 0.2. In between 11th and 100th term, the minimum value is 0.11. In between 101st term to 1000th term, the minimum value is 0.101, and then it goes on. So, from this, we can easily conclude infimum of AK, where K greater than or equal to 1 is 0.1 for all n belongs to n. So, if the infimum of AK, where K greater than or equal to n equal to 0.1 for all n, then definitely supremum is the same value. Supremum of infimum AK equal to 0.1. That means limit infimum an equal to 0.1. Now look at the answers. Options. First option, limit infimum an equal to 0, which is not correct because we know that limit infimum an equal to 0.1. In the similar way, the second option, they have given limit infimum an does not exist, but we know that limit infimum an exists. Therefore, second option is wrong. The similar way, third option is also wrong because limit infimum an equal to 0.1, but here they have given 0.15. Therefore, third option is also. From this, we can easily conclude that the fourth option will be the correct answer because first three options are wrong. Therefore, the fourth one must be the correct answer because at least one answer should be correct. Even though we know, we need to prove limit supremum an is equal to 1 is the right answer. In order to prove, now I am going to consider the boundedness of the sequence an. For that, I am taking the value of n. I just found that n is less than or equal to log power ceiling function of 10 power ceiling function of log n. From this, we can conclude n by 10 power ceiling function of log n is less than or equal to 1. That is, an is less than or equal to 1. Also, if you observe the sequence, we know that the value 1 occurs infinitely many times, because first term is 1, 10th term is 1, 100th term is 1, 1000th term is 1. If you take any 10 power nth term, you will get definitely 1. 1 will be the term. Therefore, 1 occurs infinitely many times in the sequence an, which implies supremum of ak, where k greater than or equal to n is equal to 1 for all n belongs to n, which obviously implies that infimum where n greater than or equal to 1, supremum of ak where k greater than or equal to n is equal to 1. That is nothing but limit supremum equal to 1. Therefore, the fourth option will be the correct option. Thank you.